So here's going to be an example. I showed you guys kind of basically, I gave you guys like one example basically, but now we're going to go through and do some other examples. So basically, ladies and gentlemen, what we have here is log base 7 of 4p minus 2 equals log base 7 of negative 5p plus 5. And one thing you guys notice here is that I have a logarithm equal to another logarithm, right? So if I have a logarithm equal to a logarithm, I can solve using my one-to-one property. And as long as they're the same base, I now know I have 4p minus 2 is equal to a negative 5p. Oops. What was that? Plus 5? I forgot. My bad. That doesn't make sense.
Where does the log
Plus 5.
Well, it's kind of canceling out.
It doesn't matter. What it's saying, what the one-to-one property states is if you have a log, same base of x, equal to the log, same base of y, then x is equal to y. So you don't need to write the logs anymore. It's the same thing like the one-to-one property. If I said 3 squared is equal to 3 to the x, what does x have to be? 2. That makes sense, right? You don't need the 3's. You can just say x is equal to 2. Does that make sense? So this is the same thing. If you have log base 7 of this and log base 7 of that, then you know that this has to equal that. Does that make sense? So you don't really need the logs anymore. So now, can we solve 4p minus 2 equals 5p equals negative 5p plus 5? Yeah, of course we can, right? All we simply need to do is add a 5p to both sides. So I get 9p minus 2 equals 5. Add 2, add 2. 9p equals 7. Divide by 9, divide by 9. P equals 7 ninths. Now, it is important in logarithmic equations to make sure that we plug our answers back in to make sure that they would work.